What if I told you OpenAI just made a powerful AI model 25 times cheaper than its flagship without making it 25 times less intelligent? That sounds impossible, but that's exactly what makes GPT 5.6 so interesting. Luna itself became 5 times cheaper compared with its original launch price, but compared with GPT 5.6 Sol, OpenAI's flagship model, Luna is now 25 times cheaper per token. And on one specific benchmark for professional work, Agent's Last Exam, OpenAI reports Luna beating Claude's Fable 5 at a cost per task that's nearly 99% lower. That's not frontier models in general. That's one benchmark against one named competitor. Worth remembering before you take it as gospel. So, how did OpenAI do this? Did they simply make a smaller, weaker model? Not really. The more interesting story is that OpenAI is trying to make the entire AI system cheaper. The model, the GPUs, the inference engine, the context, the tools, and even the AI agents themselves. Let's break it down. GPT 5.6 comes in 3 tiers: Sol, Terra, and Luna. Quick timeline, because it matters. GPT 5.6 first showed up on June 26, 2026 as a limited preview, gated at the request of the US government to roughly 20 approved companies. It went fully generally available on July 9, 2026. Then, on July 30, OpenAI cut prices again. Think of the 3 tiers as points on the AI intelligence versus cost curve. Sol is the flagship, Terra is the balanced option, Luna is designed for massive-scale, low-cost work. The current API prices after that July 30 cut make the difference obvious. GPT 5.6 Sol costs $5 per million input tokens and $30 per million output tokens. Terra costs $2 and $12, and Luna just 20 cents for input and $1.20 for output per million tokens. So Luna really is 25 times cheaper than Sol on both ends. That math holds up. But here's where things get interesting. The intelligence gap isn't anywhere near 25 times. Take software engineering. On SW-Pro, a benchmark that tests whether a model can produce a correct pull request against a real messy GitHub repository, Sol scores 64.6%, Terra scores 63.4%, Luna scores 62.7%. Think about what that means. A model costing a fraction of the flagship performs almost identically to it on this benchmark. Now in fairness, and this is the part that gets left out of a lot of the hype coverage, 64.6% isn't actually the best score on SWE-Bench Pro. Anthropic's Claude Fable 5 scores 80% on the same benchmark. Claude Mythos 5 scores even higher, around 80.3%. That's a real gap, over 15 points, and OpenAI didn't hide it. They published their own critique arguing a chunk of SWE-Bench Pro's tasks may be flawed. Maybe they're right, maybe they're not. Either way, it's the one place GPT 5.6 clearly trails. Where Sol does lead is agentic, long-horizon work, things like the Artificial Analysis Coding Agent Index, where Sol scores highest of any model tested, and Agent's Last Exam, where it beats Fable 5 by over 13 points. So it's less GPT 5.6 is smarter, and more different benchmarks reward different skills. On extremely difficult reasoning tasks, Sol still pulls well ahead of Terra and Luna internally, so these 3 models aren't identical, and that's actually the point. OpenAI isn't trying to make 3 identical models, it's creating 3 different economic levels of intelligence. Imagine you're running a huge software company. Your AI coding agent performs thousands of operations. It reads files, runs tests, searches documentation, renames variables, fixes simple errors, writes boilerplate, analyzes logs, and occasionally, it hits a genuinely difficult architectural problem. Would you use the most expensive model for every single operation? Probably not. You'd want something more like this. Simple task? Luna. Medium complexity task? Terra. Extremely difficult reasoning? Sol. And suddenly, the economics change. You aren't paying flagship prices for work that doesn't require flagship intelligence. This is the first big idea behind GPT 5.6. But there's another layer. And this is where things get much more technical. When people think about AI cost, they usually think, how much does 1 million tokens cost? But that's only part of the story. The real cost is, how much computation does it take to complete the task? Imagine 2 programmers. One solves a problem using 20,000 lines of temporary code. Another understands the problem and solves it in 5,000. If both produce the same result, the second programmer is more efficient. OpenAI is trying to make its models behave more like that second programmer. Instead of simply thinking more, the goal is to think more efficiently. Fewer unnecessary tokens, less wasted reasoning, more useful work from every unit of computation. And that brings us to the infrastructure. Running a frontier AI model is enormously expensive. We're talking about huge GPU clusters operating around the clock. So even a small efficiency gain becomes incredibly valuable when multiplied across billions of requests. OpenAI has been optimizing things like load balancing, GPU utilization, caching, batching, GPU kernels, sharding, and speculative decoding. Let's simplify speculative decoding. Imagine you have a very powerful but slow expert and a smaller, much faster assistant. Instead of asking the expert to generate every token one at a time, the smaller draft model predicts several tokens ahead. Then the powerful model checks them. If they're correct, those predictions get accepted much faster than generating them one by one. Here's the confirmed number. OpenAI says these improvements produced more than 15% better token generation efficiency. And separately, rewriting the underlying GPU kernels, literally in Triton and Gluon, OpenAI's own GPU programming languages, cut serving costs by 20%. And here's the genuinely fascinating part. Confirmed straight from OpenAI, GPT-5.6 Sol did this work on itself, running inside OpenAI's own codex environment. It designed and ran hundreds of architecture experiments on the smaller draft model, launched and monitored its own training runs, and stepped in autonomously when it hit hardware failures or training instability. In other words, AI helped engineer the machine that runs AI. That's a very different kind of feedback loop, and it's the reason OpenAI gives for being able to cut Luna's price by 80% and Terra's by 20%, on top of the tiering itself. And then we reach the part that's especially important for coding agents. The agent harness. Modern AI agents don't just answer one question. They can work for minutes or even much longer. They open files, call tools, run commands, read output, make changes, run tests, read errors, try again. Every action can create more context, and context costs money. Imagine an AI agent working on a large codebase. At first, it has a few thousand tokens of context. Then it reads 10 files, then 20. A test produces thousands of lines of logs. A tool returns another huge response. Soon, the model is processing enormous amounts of information, some of which isn't even relevant anymore. That's wasteful. So modern agent systems are getting smarter about context. Tools can be discovered when they're actually needed. Tool outputs can be limited. Repeated information can be cached. Completed work doesn't always need to be reprocessed. This matters because the cost of an AI agent isn't just the cost of its final answer. It's the cost of everything it does to get there. And OpenAI is trying to cut the wasted work along the way. GPT 5.6 Sol. This is the heavyweight. Use it for genuinely difficult problems. Advanced coding. Long-running agents, scientific reasoning, complex research, computer use. Sol leads by a wide margin on benchmarks that test real GUI and browser interaction. Difficult debugging, situations where getting the answer right is worth spending more compute. GPT 5.6 Terra. Probably the most interesting middle ground, substantially cheaper than Sol, while staying extremely capable. On several coding agent benchmarks, it's essentially tied with Sol, and it matches or beats OpenAI's own previous flagship, GPT 5.5, at roughly half the price. For companies running huge volumes of AI requests, this could be the sweet spot. You don't necessarily need the most intelligent model, you need the best intelligence per dollar. GPT 5.6 Luna, the economic weapon. At 20 cents per million input tokens and $1.20 per million output tokens, it's built for scale. Think about all the tiny tasks inside an AI application: classification, summarization, simple coding changes, testing, formatting, data extraction, tool orchestration, routine decisions. You can run enormous volumes of that work through a model like Luna, and when something genuinely difficult appears, you escalate it. Worth flagging honestly though, Luna isn't strong everywhere. Its long context recall drops off sharply on very long documents. Independent trackers put it well behind Sol there, so it's excellent for short, bounded tasks, and a poor fit for handing over an entire codebase or a huge log file. Luna doesn't have to beat Sol. It just has to be good enough to make cheap intelligence useful. That's a much more powerful idea. Benchmarks are basically standardized exams for AI models. They help us compare coding, reasoning, browsing, computer use, mathematics, and other capabilities. But no single benchmark tells the whole story. That's why you look at several. On agentic coding benchmarks, Sol leads. Terra is surprisingly close. Luna gives up some capability but dramatically cuts cost. On harder mathematical and abstract reasoning, the gap widens. And on production bug fixing, SWE Bench Pro specifically, Claude's models are still ahead, so the honest pattern is, Sol maximizes intelligence, with one clear weak spot. Terra balances intelligence and cost well. Luna maximizes cost efficiency, with real limits on long context. Because the future of AI probably isn't, which single model is the smartest? It's which model should do which job. Imagine a system like this. A router receives your task. Luna handles the easy parts. Terra handles the normal work. Sol handles the difficult reasoning. Other agents work in parallel. Tools interact with the outside world. Caching prevents repeated computation, and the system constantly decides how much intelligence should we spend on this particular problem. That's a genuinely different way of thinking about AI. There's another piece worth mentioning here, programmatic tool calling. Normally, an agent bounces back and forth. Model, tool, model, tool, model, tool, and every trip back to the model costs time and computation. With programmatic tool calling, the model can generate a workflow that calls multiple tools together in one pass, instead of checking in after every single step. Fewer round trips, less overhead, lower latency and cost. OpenAI has cited real examples, one financial research use case that matched quality while using 24% fewer output tokens and finishing 28% faster this way. So where is OpenAI heading with all of this? The signal is what they're calling a price-performance frontier. OpenAI doesn't just want every new model to be smarter, it wants every generation to deliver more useful intelligence for less money. That's why the Sol, Terra, Luna structure matters. Sol pushes the frontier. Terra brings high-end intelligence down to a practical price. Luna makes powerful AI cheap enough for massive-scale workloads, and these tiers can each improve on their own schedule. A naming system OpenAI built specifically so a future upgrade to one tier doesn't force a rename of the whole family. So we could eventually have a future where a system automatically chooses between different levels of intelligence without you even knowing which model is being used. You give it a goal. The system decides how much compute that goal deserves. Did OpenAI make GPT-5.6 Luna 25 times cheaper overnight? Not exactly. Luna itself became 5 times cheaper compared with its original price in a July 30 price cut, but Luna is now 25 times cheaper than GPT-5.6 Sol on token pricing. And on that one specific benchmark against Claude Fable 5, the difference in total task cost gets dramatically larger still. But the biggest story isn't the number 5, or 20, or even 25. The bigger story is this. OpenAI is attacking AI cost from every direction. Better models, more efficient reasoning, better GPU utilization, better kernels, speculative decoding, caching, smarter context management, smarter tool use, intelligent routing between models. That's how you make AI cheaper, not by simply making the model smaller, but by wasting less computation everywhere. And that could have a real consequence, because when intelligence gets cheap enough, you don't just use AI for the important tasks. You start using it for everything. Millions of coding operations, millions of small business workflows, millions of research tasks, millions of automated decisions, and eventually, entire AI agents working continuously in the background. That's the promise behind GPT 5.6. The future of AI may not be about finding one giant model that does everything. It may be about building a system that knows when to think hard, when to think cheaply, and when not to waste computation at all. And if OpenAI keeps pushing that curve downward, the most important question won't be, how smart is the AI? It will be, how much useful work can $1 of AI intelligence actually buy? And that is where the next AI race is going to be fought. That's all for today in Dots and Arrows. Thanks for watching.